Hi, I'm Lars Bergstrom, Director of Engineering for the Android Platform Programming Languages team. Together with my colleague Jeff, we're going to talk about both why and how to adopt Rust, using our own adoption here at Google on Android to illustrate a bunch of the points. So if you're here, you've probably already heard about Rust, a new programming language designed around three big pillars. First, it provides full performance and control you need to write systems programs that are in direct control of the hardware resources. Second, it provides safety from a variety of errors around the misuse of memory or concurrent thread execution. And finally, it has a modern take on providing mature documentation and tooling around all aspects of the language and its ecosystem. So most people come to Rust because of the unique combination of those first two pillars: performance and control with reliability and safety. In most languages, you have to choose one or the other. Languages like JavaScript, Kotlin, and Java have compile time or runtime prevention of threading or memory corruption issues, but they abstract away your access to the machine. On the other side, the C family of languages provides that access, but with little in the way of safeguards. So increasingly, our projects really need both of those. Speaking for Android, our devices rely on taking advantage of parallelism while dealing with many complex concurrent events. Mobile phones continue to increase the amount of parallelism through more CPU cores. And scaling via that parallelism instead of jacking up the frequency of the CPU is a key way for our users to have a great flicker free experience without hurting their battery life. But at the same time, we have myriad devices, phones and tablets, headphones and TVs, all of which are communicating concurrently with each other and introducing a lot of complexity that makes it really hard to build stable systems. Rust is the only language we know that gives us both the performance and the safety that we need. But of course, it's not just about the language itself. The code we write is often a small portion of the overall deliverable. In a system like Android, over three-quarters of the source code, 75 million of the 100 million lines of code, are third-party ecosystem libraries that we rely on. And Rust makes it easy to integrate and update those dependencies, and that's something we haven't really had with C or Java. There's also a really consistent story around the code style and warnings. Rust format provides code style defaults that you'll see across the entire ecosystem, and Clippy enforces appropriate use of coding patterns. That means in every Rust project you run into, you'll be able to understand the code. There aren't the sort of local dialects that you get with C++, where every company and every project has chosen some different subset or stylistic way of using the language. Beyond the tooling, though, the Rust project was one of the first language communities to adopt and enforce not only a code of conduct, but norms around being welcoming to developers, no matter what their prior background is or what industry they're working in. This means that for new adopters of the language, it's easy to get early feedback and guidance on your journey. But just being an amazing language with great tooling and a fantastic community isn't really sufficient for most businesses to make the big investment of supporting a new language. Beyond the cost of adding the tools to the system, there's training, there's hiring, there's interop with all of your existing code, just to name a few. So, what's the business case? At least for Android, the case is pretty easy: security. As an operating system delivering code to over 3 billion devices, the cost to our users, partners, and Google itself is really high for each and every security issue. And of those security issues, the vast majority of them are memory safety bugs. Now, we've invested heavily in hardware features, improved our compilers, built static analyzers, and dynamic sanitization tools to try and address this issue. But the exploits continue to be found faster than we can keep up with them via tooling. So for us, and especially in new code that we're writing, Rust is absolutely the smartest choice. It protects us from the entire class of memory safety bugs right from the start, and it's already paid back our investment in it on Android. Of course, it doesn't hurt that the teams who have adopted Rust really enjoy working with it. Here's a quote from the technical lead of the Bluetooth team. There was a marked shift implementing things in Rust. After you compile, you know it's not going to blow up in unexpected ways, so you can focus on the complexities of Bluetooth rather than the code exploding. Bluetooth is really complicated. There are many specifications, not all of which are perfectly implemented by the devices. And even if they were, devices can come and go at unpredictable times, leading to some really deep complexity that you have to capture in the code. Let's take a look at some of that code to see an example of that. So the details here aren't really important. The code on the left is the existing C++ code for the previous version of the Bluetooth stack. It's highly asynchronous, with handling many hardware events, timeouts, and software commands. It's a big pile of functions littered with asserts, state machines embedded in opcodes, and a bunch of unit tests you can't see off to the side. Understanding all of the interactions and the various machinery involves reasoning about that entire system in order to make any change. On the other side, though, the Rust code can use the built-in asynchronous functions and embed the whole state machine, including all the timeout conditions, in a single dispatch loop. This not only makes writing the code easier, but also modifying it later to make sure that you didn't introduce some new error state or mishandling a command where you handled it in one place but you missed it in another. The compiler will automatically catch all those cases for you. So, most importantly, it means that you don't have to be an expert in the entire system to either make a change or to review one. Another early adopter of Rust in Android was the security team. So, to quote one of their technical leads, after writing Rust code for a year, the kind of flawed code that C++ compilers would tolerate due to C++'s specified tolerance for undefined behavior appears ridiculous. So we see this over and over. Not only does Rust make it possible for people without a systems programming background to write great code, but even people with decades of experience writing and shipping production C and C++ see the benefits of Rust. Writing performant and safe code in existing languages is just too hard. So we've looked a bit at the why of adoption. Now I'd like to hand over to my colleague Jeff to talk about the how of adoption. Take it away, Jeff.
Thanks, Lars. I'm Jeff Vanderstoep from the Android security team. And as Lars mentioned, security was a big motivator for adopting Rust in Android. But of course, security is only one of the many stakeholders in the room. There were a number of important problems that needed to be solved and risks that needed to be addressed before we could move forward. The first question that we needed to answer was, does this actually solve a problem? If you've been around the industry for a while, you've likely developed some pessimism that the next tool, training, or mitigation is going to fix our problems with memory safety, or even substantially raise the bar. But why is that? Iterating and incrementally solving problems is a tried and true engineering technique. And for the past 30 years now, and particularly the last 10 years, we as an industry have been working hard on making C and C++ safer. Part of the problem, I think, is that we've been chasing the wrong metrics for success. There's been a lot of focus on the number of vulnerabilities found or prevented, but really that needs to be considered within the context of the entire problem. Like my picture here of Piglet shows, ineffective problem solving, we can't just focus on removing bugs. We need to step back and say, are our efforts actually resulting in vulnerabilities becoming rare? Of course, we have a good way to prevent memory safety vulnerabilities, memory safe languages. But a critical difference between today and 10 years ago is that today we have a memory safe language that can be used in all the same places where we currently use C and C++. But then we have tens of millions of lines of C and C++ code. So does switching to a new language actually help? To answer that question, we did an evaluation of all the memory safety bugs reported to Android in 2021. We see that they're unevenly distributed across our code base, with new or recently modified code having a much higher frequency of vulnerabilities. The key takeaway for this is that if we want to prevent memory safety vulnerabilities, switching new development away from C and C++ to Rust will immediately have a large impact, not just on our total number of vulnerabilities, but on the teams that own that code. Teams writing Rust will have a significantly lower overhead devoted to bug and vulnerability remediation. They'll get to spend their time on other things like writing new code. And while we did this analysis on Android, I would note that similar results have been demonstrated on other large code bases. And it's very relevant. It's likely relevant to your code base. So you don't need to rewrite everything to get the benefits of switching to a memory-safe language. Another big area that we needed to investigate was how will Rust integrate into our existing systems. So for Android, we needed to evaluate two areas. The first was how will Rust interop with our other programming languages? And the other was how will we integrate support with Android's custom build system? So I've included links to blog posts here that we've published that include all of the details of how we went evaluating both of these areas. But here I want to specifically talk about language interop because we wasted a lot of time initially on looking at general interop between Rust and C++. So don't do that. Instead, focus on your existing code base and where you'll need interop. For Android, that was pretty easy to approximate for Rust to C++ by looking at how we reuse C++ throughout our code base. In other words, if we commonly reuse functionality from C++ across different projects, we'll likely need to use that same functionality within our Rust code for the same purposes. With that knowledge, we were able to add interop solutions that fulfilled Android's needs. For us, that was a combination of common tools like BindGen, the CXX crate for creating bindings to C++ code, and we also had some carefully chosen native bindings that we made. For example, to generate Android's interface definition language. So a risk that we needed to address was, what if we change our mind? Long-term commitment to a language is costly, and it's genuinely difficult to know until it's in use if it was the right decision. One way that we helped to make this decision easier was by setting up our early efforts as a reversible pilot. This provided our leadership with the opportunity to evaluate support before giving approval to move out of the pilot stage, which we have since done. And finally, there's a lot of other stakeholders. So who needs to sign off? We had to do a lot of work to convince folks that Rust was the right decision for Android. And if you're considering Rust for your project, you may need to do the same. Some areas where I think you're good to go are security. Rust is an obvious choice for system software and an obvious way to avoid the high vulnerability density of C and C++. Another area was performance. And if you're currently using C++, you're likely very concerned about performance. There's a lot of public data available on this. And if you're skeptical, like we were, you can do your own investigations on performance. Multiple independent teams within Google have confirmed that Rust's performance characteristics are remarkably similar to C++ on an apples-to-apples comparison. Finally, there's a lot of other areas, and a lot of additional due diligence was needed to make sure that Rust integrated well with our existing systems. Some of this was just verifying, for example, that crashes were picked up by a crash reporting system, but other things required improvements that you will benefit from and that we upstream to the Rust project, such as build reproducibility. So the last large area that I wanted to address was that what if no one knows Rust, or what if you only have a small team that knows Rust? How do you get started? So for us, we started with a small core team, and that could really be just a couple of people, and use that team to bootstrap other teams and people. So first, we onboarded early adopter projects where users were interested in learning and tolerant to integration speed bumps. And by speed bumps, I mean, a third-party library that they needed wasn't available, or a build feature that they needed wasn't available. And so we would help them, but as I said, they needed to have some tolerance to delays like that. The other thing that we did was, I've called it no free-for-alls. And what I mean there is that we didn't just allow everyone to start using Rust immediately. We actually scaled very intentionally. We chose projects carefully, and we used technical means to enforce those decisions. So for us, that means that we actually had technical enforcement of which projects within the entire Android open source project were actually allowed to use Rust. Finally, as you're scaling, the people and teams that you've onboarded become part of the scaling effort, and they in turn help onboard new teams and people. So finally, where we're at in the process is that we continue to scale up. We're onboarding new teams, new projects are launching within Android that are using Rust, and we actually just recently hit an exciting milestone where we removed those technical means within our system for restricting who can use Rust. So now any team working on the Android open source project is allowed to use Rust. And thanks for joining us for adopting Rust on your team. And let us know if you decide to use Rust on your project.